So in this video, we're going to go over, we're being asked to solve a linear equation. And this is a lot of what algebra is based upon, although they don't necessarily say solve a linear equation or anything. But the steps used in solving a linear equation will also be used to solve a lot of other equations that we go over later on. So it's important to understand how we're doing these things so that we can solve the equations for later on. So this first equation that we're given is to solve for x, the equation negative 4x plus 8 plus 2 equals negative 3 times x minus 5. So first of all, this equals sign here, this doesn't, when you've got unknowns, it doesn't mean that it's absolutely equal to. It means it's the equivalent to. It's the same thing. That if you evaluate this side of the equation and evaluate this side of the equation, they're going to be equivalent. So it's what, and you'll see what we can do is when we state it that way, is we can do anything we want to one side of the equation as long as we keep it equivalent, we keep it balanced, and we do the same thing to the other side of the equation. So first thing we can do is get rid of these parentheses because we're adding here. So we can just simplify this left side of the equation as negative 4x plus 8 plus 2, so that gives us plus 10. And on the right side of the equation, we can multiply using the distributive property. So negative 3 times x is a negative 3x. And then a negative 3 times a negative 5 gives us a positive 15. So again, we haven't changed this value of the overall equation at all. We've just simplified it a bit by getting rid of the parentheses, by multiplying it on the right-hand side, and just by adding over here. So now what we can do is we can isolate the unknowns on one side of the equation and our constants on the other side of the equation. So let's isolate the x's on this side of the on one side of the equation. So we've got 4x plus 10 equals negative 3x plus 15. Well, I can come in here and I can subtract 10 from this side of the equation. As long as I do the same thing to the right side of the equation to keep it equivalent, to keep it balanced. We haven't changed the value of the equation at all, we're just rewriting it. So negative 4x plus 10 minus 10 is 0. So that equals to negative 3x plus 15 minus 10, that gives us a positive 5. All right, now we can do the same thing with this negative 3x term here and move it, essentially move it over to the other side of the equation. So we have, if we have a negative 4x, let me back up here. If we have negative 4x equals negative 3x plus 5, if we add a positive 3x to this side of the equation, we can add a positive 3x to this side of the equation, and we haven't changed our overall statement at all, or we've just rewritten it a different way. As long as we do the same thing to both sides of the equation, we can do that. So negative 4x plus 3x gives us a negative x. And then negative 3x plus positive 3x gives us 0, plus 5 gives us 5. So now we say a negative x equals 5. Well, if a negative x equals 5, then a positive x, if we divide both sides or multiply, either way, if we divide both sides by a -1, then we'll get x equals -5. And again, in all this, we didn't change this original statement. We just rewrote it in different ways so that we could solve our equation. And we'll do the same thing to the second one. It'll look a little bit harder because there's fractions involved, and I know fractions, everybody seems to hate fractions, but what are you going to do? They're essential. All right, 5 equals x plus 3 over 8 minus x minus 2 over 3. Now, if you remember about fractions, we can't just go in and subtract this. We can't just say x minus x and then 8 minus 3, because 8 minus 3, you have to have the same number in the bottom here, in the denominator, to do any kind of addition or subtraction with fractions. But what we can do is just ignore that altogether if we multiply both sides of this equation by this lowest common multiple, which in this case would be 24, and I'll show you how we get that here. I mean, the easiest thing to do is just say, 8 times 3 is 24. So, like we did in the first problem, if we do the same thing, if we multiply both sides by 24, we're not changing this equivalence. So 24 times 5 is equal to x plus 3 divided by 8 minus x minus 2 divided by 3, the whole thing times 24. Well, 24 times 5 is 120. Is that right? No. Yeah, it's 120. Okay. So now, this x plus 3 times 8, we'll just go ahead and multiply that out so you can see what we're doing here. 24 times x plus 3, that's a plus, divided by 8. And we can rewrite that as minus 24 times x minus 2 divided by 3. Now, when we have a number here that we can divide, instead of multiplying it all out and then dividing it, we can say, okay, 24 can be divided by 8, so that 8 will cancel out with that 24, and then we'll be left with 3. So then we'll have 3 times x plus 3, and then there's no more fractions here. And then we can do the same thing here. Okay, 3 goes into 24 8 times, so then we'll have a minus 8 times x minus 2. And again, in all this, we haven't changed the value of our original equation at all. We're just rewriting it in different ways. So that's something that we can work with. Now we can come in and work with it and say, okay, 3 times x is 3x. 3 times 3 is 9. Minus 8 times x is a minus 8x. Minus 8 times a minus 2 is a positive 16. So that's equal to 11x, 3x, excuse me, signs again. 3x minus 8x, it gives us a minus 5x. 9 plus 16 gives us 25. So we have a minus 5x plus 25 equals 120. So now we can come in and say, okay, 120 minus 25 equals minus 5x plus 25 minus 25. So 120 minus 25 gives us 95. Minus 5x plus 25 minus 25, that's 25 minus 25 is 0. So that gives us minus 5x. So if we divide both sides by a negative 5x, we will find out what the value of 1x is. And we find that x is equal to, let's see, that goes into, that's a negative 19. So when x is negative 19, this original statement is true. This one up here. And we can find that out really quick. Negative 19 plus 3 is a negative 16 divided by 8. That gives us a negative 2. Negative 19 minus 2 is a negative 21. So that's so the minus 19 minus 2 is a negative 21 divided by 3. That's a negative 7. And you'll have a minus a negative 7, which is a positive 7. So you'll have 7 minus 2, and that gives you 5. So that's essentially how you solve these linear equations, but that's also the basis for solving most of the problems that most of the equations that you'll have in algebra. Is you have to isolate your unknowns on one side of the equation and your knowns on the other, and you can do the same, as long as you do the same thing to both sides of the equation, you'll be fine as far as finding out what the solution is. And once you master that, then everything else follows with that.